All right, part 2 of chapter 12.8, and this is, last night we did with replacement, now we're going to do without replacement. These are dependent events. So dependent events are when the second thing depends on the first thing. So without replacement, that's definitely a dependent event. The question says, suppose you choose a tile at random from the tile shown on problem 3. Without replacing the first tile, you select a second tile. What is the probability that you choose a dotted tile and then a dragon tile? So, just to refresh your memory from that video, there were 3 dragon tiles. There were 4 dotted tiles. There were 5 squares, 2 birds, and 1 flower. On the tiles. This is from the video from the night before. So that means there are 15 total tiles, and they're asking without replacement, and they're going to be very specific about these questions, so you have to really watch the wording. When you see without replacement, that is a dependent event, and I need to find out what's the probability that I choose a dotted tile and then a dragon tile. So the probability of a dotted tile, that part's going to be easy. I'm trying to find the probability of a dotted, then dragon. So that's going to be the probability of a dotted times the probability of a dragon after you pulled the dotted one out. So the probability of a dotted tile is going to be 4 out of 15. So after I pull that dotted tile out, there are now 14 tiles in there. So the probability of a dragon tile is going to be 3 out of 14. When you multiply that, you get 12 over 210. Which is going to reduce to 2 out of 35. Okay, and then the question down here on the bottom, it's not a guided question. What's the probability that you'll randomly choose a flower and then, without replacing the first tile, a bird? So, the probability of a flower is 1 out of 15. If I don't put that back, the probability of a bird is going to be 2 out of 14, which is going to be 2 out of 210, which reduces to 1 out of 105. All right, then this is the last example. 1 freshman, 2 sophomores, 4 juniors, and 5 seniors received top scores in a school essay contest. To choose which 2 students will read their essays at the town fair, 2 names were chosen at random from a hat. What's the probability that a junior, then a senior are chosen? So, you're not going to put the person back because you don't want to draw their name twice. So you kind of have to use a little common sense when you're talking about probability. But you're going to find the probability of a junior, then a senior. So that's going to be the probability of a junior times the probability of a senior after a junior. So the probability of a junior is 4 out of 12 out of 12. Yeah, 5 and 9, 5 and 4 makes 9, and then 2 is 11, and then 1 is 12. So 4 out of 12. And then the probability of a senior after that is going to be 5 out of 11. Which, if you multiply, you get 20 out of 132. And I know that 2 will go into all of them, but it may reduce more. If I divide it by 2, I get 10 out of 66. But if I reduce it more than that, divide it by 2 again, I get 5 out of 33. So that's my probability. And this question down here at the bottom, what's the probability that a senior then a junior is chosen? So that's going to be 5 out of 12 times 4 out of 11, which is 20 out of 132, which is going to be the same thing. So order might not matter there. All right, here's your Got It questions, 5 questions again. Write them on a separate sheet of paper, bring them to me tomorrow. If you have any questions, make sure you contact me. If not, I'll see you tomorrow.